This video goes over the Unit 2 review. For this section on infinite and no solutions, these are the steps for all the problems. The first thing we do, if applicable, is to distribute. So for example, here we simplify this to 2x minus 14. Same thing happens over here, 4x plus 12. Next, we combine like terms. The numbers on the left are combined, the x terms on the right are combined. Here we combine the x terms on the right. There are no like terms to combine here. The 12 and the minus 9 simplify like this. The 42 and the 1 give us 43. The 5x minus 2x gives us 3x. And the 4x and the minus 7x combine to give us negative 3x. So I've distributed, I combine like terms. Now we take a look, is there an x on both sides? And for all of these problems, the answer is yes, there is. So then we take a look at, are they the same or are they different? For example, 3x is 3x, they're the same. So this is going to be a special case. There's going to be either infinite or no solutions. How do we know? We look at the numbers. Because they're different, this one is going to be no solution. Next up, the x terms are the same. There's a negative 2 in front of both of them. The numbers are also the same. Because everything is the same, that means there's infinite solutions. Here I see 1x and 2x. They're different. That means I'm going to solve it for one solution. So I'll come back to this one. Same thing here. I have 4x and 3x. So there's going to be one solution. I'll come back and solve this one. Down here I see 3x and 3x. And are the numbers the same or different? Because they're different, this is going to be no solution. Negative 3x and negative 3x are identical. 5 and 5 are identical. So this one's going to be infinite solutions. To recap, when the x terms and the constants are identical on both sides, infinite solutions. When the x terms are the same but the numbers are different, no solution. So if we look at our steps, we have identified all of the ones that are infinite or no solutions. If there's one solution, then we need to cancel out an x. Cancel out an x. So for example here, I could do minus x on both sides. And this gives me 3 is equal to x minus 14. I'll do the same thing here, but this time I'll do minus 3x. And I'll get x plus 3 is equal to 27. Now it's a two-step equation, or maybe even less. These both look like one step. So we're next going to undo any addition or subtraction. What does that look like? Plus 14 to both sides. Minus 3 to both sides. And the answer is 17 is equal to x, or 24 is equal to x. If there was a number in front of x, the last thing would be to divide. Or if there was a fraction, to multiply. Next up, absolute value equations. There's 3 things to remember. One is that we must solve for the absolute value. That means anything outside the brackets we cancel out, but the stuff inside the brackets we leave it alone. The second thing to remember is that there's going to be 2 equations each, the positive answer and the negative answer. And the third thing to remember is that absolute value will never be negative. So if that ever happens, you know that it's no solution. So here, the absolute value is already solved for itself. We see that the absolute value of x is 7. So when we split to a positive and a negative answer, over here is x is 7, over here is x is negative 7. This is negative, so the answer is going to be no solution, because absolute value will never come out negative. Whatever you plug in for x, it's always going to come out positive. Next one, first thing to do is add 1 to both sides. And now that I have the absolute value all by itself, I can split into a positive and a negative equation. At this point, the brackets are gone. And I have equals 1 on the left and equals negative 1 on the right. So all I have to do is add 1 to both sides for both equations. And we see that either x is 2 or x is 0. Both of these work. 2 equations, 2 answers. This 2 in front of the bracket implies multiplication. So the first thing we do is we deal with the subtraction instead. Now we have 2 times the absolute value of x plus 7 is equal to 0. If we divide by 2, that still gives us 0. So if we tried to split into two equations, there is no real positive and negative 0. In both cases, it's just x plus 7 is equal to 0, which is the same thing. So we only need to do it once to find out that our only possible answer is negative 7. We subtract 12 from both sides. We have negative 2 times the absolute value of x minus 2 is equal to negative 8. Then we divide by negative 2. Even though it looks like we're subtracting there, because it's right next to the bracket, it's just like with parentheses, where it implies multiplication. So good news, this one comes out positive. We can actually solve it. We have a positive and negative solution. X minus 2, the brackets are gone, is a positive 4. X minus 2, the brackets are gone, is a negative 4. If I add 2 to both sides, my first answer is 6. And my second answer is negative 2. I add 3 to both sides. I have 4 times the absolute value of x plus 3 is equal to negative 11. And when I divide by 4, it doesn't really matter because there's going to be no solution, because the absolute value of anything can never be negative. When it asks for what is r in terms of things, that means my final answer will look like this. R equals something. So whatever is there, I'm going to cancel it out. RT implies a multiplication. So I divide to get r by itself. There's not an actual numerical answer, we just rearrange the formula, or the equation. Similar thing here, my goal is to get p equals something, so I have to cancel out whatever is there. Since it's multiplication, I can rewrite this as t divided by 0.8. Because dividing and multiplying cancel each other out. Think about there being parentheses here. So therefore, the first thing I do is I multiply both sides by 2y. Notice I'm putting it on the top of the fraction because they're going to cancel out. So I have 2yz is equal to x plus 3. If I subtract 3 from both sides, well, what is 2yz minus 3? You just write it. Since density is on the bottom, I can multiply by whatever's on the bottom, and I get dv is equal to m. Since I want to solve for d density, I can divide by v. d is equal to m over v, as the v's cancel out. Think about there being parentheses here on the top of the fraction. That tells me to multiply by 6 first, and this part goes away. So I have 6e is equal to o plus 4m plus p. I'm going to subtract the o and the 4m at the same time. And I have 6e minus o minus 4m is equal to p. This is a challenging problem here. There will be an easier one on the actual quiz, but let's take a look. It's like there's parentheses down here at the bottom, so we can multiply by n plus f on both sides. What that gives us is this. Then we can distribute the r. That gives us Rn plus Rf is equal to f. And let's put all the f's over here on the right by subtracting. So we have Rn is equal to f minus Rf. And this is where we do the opposite of distributing. We pull out common factors. And we can rewrite this as Rn is equal to f times 1 minus r. Finally, we divide by 1 minus r on both sides. And there's our answer. I think it's more likely that you would see one like this. Let's say xy plus xz is equal to q. You would have to factor out a common x and write it like this. X times y plus z is equal to q. And assuming you were solving for x, we're going to divide by y plus z. And that would be your answer. This one on the left is a real SAT problem. And this one on the right is probably more in line with what you would have to do on the Delta Math this week or the actual quiz.